This is a video for part 4. We still continue the chapter 5.2 about the Sankey diagram. Now you have learned that energy can be converted from one form to another. You have learned the law of conservation of energy. So we can use a Sankey diagram to show the energy conversion process. Now I will give you this example. This is a light bulb. Okay, this is a light bulb. This is called incandescent light bulb, or in Cantonese you will be more familiar with the following term, 烏絲燈膽嘅. So for this light bulb, for every 100 joule of electrical energy supplied to a light bulb, only 10 joule of them is converted to light energy, and the remaining 90 joule of them is converted into thermal energy. So what are the useful and non-useful energy form? What are the energy input and energy output for this case? The energy input will be 100 joule electrical energy, and the energy output, there are two of them, 10 joule of light energy and 90 joule of thermal energy. Although we have two different kinds of output, for the use of the light bulb, only the light energy is a useful energy form. The 90 joule of thermal energy, they are non-useful energy form. It is a waste. We don't use the light bulb to get warm by this case. So how can we use a diagram to present this energy conversion and showing how much energy is useful and not useful? So the Sankey diagram will help us to illustrate what are these numbers. The Sankey diagram will look like this. 100 joule electrical energy. You see only a small amount of them is converted to light energy. A large amount of them is converted to thermal energy. As they're not useful, the arrow will point to the downward position to indicate that they are not useful. Now for the Sankey diagram, you see we have different width of the arrows. The width of the arrows, actually they are in the scale to the amounts of energy for each type. As you have learned it in last part about the law of conservation of energy, so for the energy conversion, 100 joule, after conversion, the total amount of output energy the sum of them will still be 100 joule. So this obey the law of conservation of energy. So how can we construct a diagram like this to demonstrate the energy input and the energy output for the light bulb? Now the steps is already printed in the textbook, so I wish you to read these pages first before we move on to the example. Now I will use the following part and draw the Sankey diagram with all of you. So you may refer to textbook page 98. Okay, 98. I will use the following two examples to illustrate how to draw the Sankey diagram. But I want to pause the video and read this part first before I tell you how to draw the Sankey diagram. Alright, so if you're ready, we'll move on and I will illustrate how to draw these two Sankey diagrams. Okay, so here will be one of the copy of page 98. Now, sorry for my version, there's some strange icon here. Just ignore this. So just ignore this. Okay, in your textbook, you don't have this icon here. So for the first case, the projector, how can we construct a Sankey diagram for a projector? Now, first of all, this is the energy input and the energy output here. You need to think which one is the useful energy form and which one is not useful energy form. So we're using a projector. We use it to watch the movie or use it to in the classroom to show the PowerPoints, etc. So of course, light energy is our useful energy form. And the thermal energy, we are not using the projector to get warm in the winter. So it is the non-useful energy form. Okay, this is a non-useful energy form. So for the input 100 joule of electrical energy and the output only 10 joule will be useful. So if we use the Sankey diagram to illustrate this, we use the arrow. Now before you draw the Sankey diagram, there are at least two things you will get along with you: ruler and a pencil. Remember, we draw diagrams with pencils all the time. Okay, so there are 100 joule, 10 joule, 10 joule, and 90 joule. But we don't have 100 boxes here. So we can't use 100 boxes to illustrate. That means we will scale it down. So let's say I use 10 grids, 10格 or 10 grids for the edge input. Now I put 10 grids here, okay, 10格呢度. So here will be 10 grids, and this illustrates the energy input. So the diagram will look like this. We have an arrow going from the left to the right, and also here. For the scale here, I use each grid as 10 joule. So 10 grids equals to 100 joule. 一格代表10個 joule， 10格就係100個 joule。Useful energy form 10 joule or out of 100. That means we only have one grid for the light energy, useful energy output. So I'll draw it like this. So I'll keep one grid here. 淨係有一格喺度啫。Okay. Very little one. So this will be the useful energy form. Now how about the non-useful energy form? They are the thermal energy. So for a Sankey diagram, for those who are not useful, they will look like this. So the one useful will look like this. So here will be the tricky point. How can I present the energy not being useful? So I need to have somewhere. I count 9 grids from somewhere and pointing downwards. 呢度數9格先。好嗱，我就咁樣數啦。1, 2, 3, 4, 5, and then 6, 7, 8, 9. Here will be 9 grids. Okay, 9 grids. And the width of the non-useful energy form will be having 9 grids here. And later on, it's going to point downwards. So I do the following trick to make it looks better. I put the arrow here. Sorry. I put the arrows here. Alright, this indicates the thermal energy being lost. Now the last thing is we connect the arrows together and give the Sankey diagram like this. So the first one, this will be easy. Now for me, I will just use a right angle to connect the arrows. Now what does it mean? So I'll do it like this. Here we have 9 grids, so I put the arrows in this way. Oh, WhatsApp message. 有下錄添，唔緊要。Here, right angle. And then we connect them together. Actually, you finish the Sankey diagram. To make it look better, I cross out this one. And lastly, you need to give the labels. So labels will be indicating what are the energy form for this case and what is the amount of energy input. So for energy input, electrical energy. So we put the label here. Electrical energy. And the amount will be 100 joule. And then here, this one, thermal energy, 90 joule. This one, 10 joule. This is the light energy. Okay, that's it. Now some of you argue can I use the smooth lines here? So can I use a curved line instead of right angles？可唔可以兜彎？可以嘅。咁我建議你咧畫完直角先至兜彎嘅。Some of you will do it like this, okay? Will do the crossing here. But for me, I accept. I think it's easier for you to just use the right angles for the diagram. Okay, how about next one? The next one will be a little bit complicated. Hair dryer. This time, assume that the energy input for the electrical energy is also 100 joule. Now, there are three energy output. Which one is a useful energy form? I think about hair dryer. Now, we want to dry our hair. So, of course, this is our useful energy form. So, the thermal energy is our useful energy form. However, this example, we have two different kinds of non-useful energy form. So how can we present these non-useful energy form? Actually similar to this diagram. Okay, so this time I will use 10 degrees as the input energy, and I start to draw this diagram. So start from here first. Or here will be 10 degrees. This will be the electrical energy. So better I put the label first to make clear. Electrical energy 100 joule or 100 joule. And then usually I will start with the energy output, useful energy output. Or 50 joule they're useful. That means half of them will be useful. So if I extend the diagram, it will look like this. 我哋上邊嗰個畫起先嘅。For thermal energy is being useful, so it will look like this. 5格。The width is 5. There are 5 grips as 5 grips. So this is a useful energy form, thermal energy, 50 joule. Now how to present the kinetic and the sound energy? So I will have different stages for the division. Or first one, kinetic energy. Some of them is converted to kinetic energy. So I will start from here. But let's say we have an arrow pointing downwards, and the width will be 4 grids. 入落去100 joule 10格，咁你要走出嚟嘅40 joule 應該有4格。So I just count the ratio. There will be 4 grids. Alright, 4. I put the arrow here, and this one, it is kinetic energy, 40 joule. How about 10 joule of sound energy? It may be somewhere here. So the arrow will look like this, okay? Sound energy, only 10 joule. So it just occupied 1 grid. This one is sound energy, 10 joule. Now the last thing is we connect them together. Usually I will start from the useful energy output to connect the arrows here. Okay, wait. So just imagine for this stage, 10 joule of them is being lost. Together would be thermal energy. So that means originally we should have 60 joule here. So the arrow should be located here. Or some of you will think it in another way. First energy loss in this diagram is the kinetic energy. So I draw a diagram here like this. So after losing 40 joule of the energy, so the width of the input energy will lose 4 grids, 會冇咗4格。And then we connect them together. Now this is the Sankey diagram. Okay, I repeat. Originally 100 electrical energy, 100 joule kinetic energy. Now imagine for the first stage, 40 joule of them is being lost. So here we lose 40 joule kinetic energy. So the width will become 60 joule here. The width in the graph will be 6 grids. And one of them, that means 10 joule energy, is lost again as sound energy. So the Sankey diagram will look like this. Now, of course, you can make the diagram looks better by drawing some curves, but I will accept this. Okay, I will accept the right angle one. Some of you will argue, can I put the sound energy first and then the kinetic energy next? Yes, of course. So the diagram will look like this one. Alright, the diagram will look like this one. If you put sound energy first and the kinetic energy afterwards. Now, this is my textbook version. However, I prefer the right angle one. That's okay. Remember for the labeling. So my last example will be for the extra worksheet I'm going to upload to you. So I will use question number 2 in the extra worksheet for the final example. All right, final example about the rice cooker. First of all, what are the energy form input and output for this case? Input and output. Input and output. So for the energy input, it is an electric rice cooker. Of course, we are inputting electrical energy. And for the energy output, we use it to cook the rice. So we need to heat up the rice. We must have thermal energy as a useful energy output. Now, here, what are the non-useful energy output? Maybe there are many, but for this case, I give you the example. Only sound energy is being lost to the sound energy is a non-useful energy form. So how can we draw the Sankey diagram here? Now this time, for this example, the problem is the input is 600 joule, but we only have the grids here. We only have these numbers of grids here. So how should we make a beautiful in scale Sankey diagram? So we need to have some simple mathematics here. Input 600, and then one of them will be 560, one of them will be 40. So 560 out of 600, it will be here. And after calculation, it will be 14 out of 15. For 40 joule of the sound energy out of 600, it will be actually 1 out of 15. 1 part out of 15. So if I draw the Sankey diagram, I try to make the output energy and the input energy as whole numbers, integer. 最好係齊頭整數畫出嚟會靚啲嘅。So the input for 600, you can use 6 grids. 當然你可以用6格嘅。However, it's very difficult for you to measure 1 out of 15 of the 6 grids. 點6格有1/15咧？好難去畫嘅。咁我諗你用間尺去度咁樣啦。So, instead, I will try to use some numbers. Okay, try to let some numbers. So shall we use 10 grids? 我哋會唔會10格咁闊咧？如果10格嘅話，1/15，即係有啲一格半嘅咯喎。So it's not very it's not good. So maybe 咦1/15 1/4，咁不如我15格啦。Yes, this will be a good choice. 你可以15格咁俾佢嘅。Or even you will use 30 grids， 你30格嘅1/15都係個齊頭整數嚟嘅。OK， 咁我自己咧就用30格啦。OK， so I repeat. After the calculation, you find the fraction, you find the proportion out of the input energy. So to make the Sankey diagram looks better, it's better for us to have the output energy in integers the width will be integers. So a good choice will be the input is occupying 15 grids or 20 grids。咁你自己要計一計究竟個比例係幾多啦？What will be the ratio of the energy output in this diagram? Okay, so we continue. This time I'll use 20 grids. Sorry, 30. So here 10, 20, 30. So input here, I draw a large one, input. This will be the electrical energy. And then 14 out of 15 of this sorry, I make a mistake, 30. 14 out of 15 here, so that means 38 grids will be useful as a thermal energy. 咁我就畫一個好大嘅箭嘴啦。The arrow will look like this. 28. Okay, 28 of them are useful. So I'll make it like this. So they are the useful energy for thermal energy. 360 joule. 360 joule. And then 1 out of 15 will be useless. So after the calculation, that means 2 of them 兩格係會出咗嚟嘅。咁我求其畫啦。OK， 呢度攞啦。2 grids. Put an arrow here. This one will be connecting the bottom part of the Sankey diagram of the input energy. This will be the sun energy, 40 joule. Alright, I forgot to label electric energy, 600 joule this side. Finally, we connect the arrows together. This part, 2 joule of them is lost, so for the arrow here will be only have 28 grids. Okay, that's all. This is a Sankey diagram of this case. Now I need you to finish the remaining part for this worksheet. Number 1, number 2, number 4. Sorry, number 1, 3, and 4, and also the remaining part of the textbook for the checkpoint. So we'll see you in the next video.